So I feel like I can just cut the talk in half because you saw like all my speaker notes by now, so it's more of a blog post. Anyhow, so as said, I'm Hynek, and as you've already read, I'm here to make your life easier. And I want to make it easier by doing less. I want you to stop worrying about the whole complex of things in your applications. I want you to stop worrying where your logs are going and how they are processed in your applications. I want you to stop worrying where your configuration for your application is coming from, how it's structured, why it is there anyway. And I want you to stop worrying where it is running and how it got there. And instead, I want you to start thinking about your application as a building block in a construction of something much, much bigger. Because those tasks I've just enumerated, they do not go away. Someone still has to do them. But if you play your cards well, that someone is not going to be you, but someone else. So it's basically, instead of thinking about your application about a Django app that serves cat pictures, I want you to think about thinking as a universal block. And that block is something that others can work with, and you will outsource tasks that are usually not very pleasant to work with, especially if you are mainly a developer, because let's face it, we usually do not appreciate doing operations work a lot. So we are going to create a lot of SEPs today. And as a side effect of all this I'm going to teach you to not do, your application will also become web scale by accident by the end of the talk, which is kind of nice. And as with actual building blocks, it should not matter whether you're building a doghouse or an airport. And since I'm from Berlin, I know everything about airports, so you can believe me there. And this is much funnier if you know the story about Berlin's airport, because there is none. So your application should look the same to your notebook and to a huge cluster. So this is the goal. And once you get there, it dramatically simplifies your development, your testing your applications, operating your applications, and also scaling your applications. And one kind of underappreciated effect that you get too is that moving to new platforms becomes much easier too. And platform agility is a much bigger deal than you may think right now, because every infrastructure evolves over time. Trends come, trends go, and you will have to touch that CentOS 5 server eventually, unless you go extinct. So even if you're happy with your state-of-the-art Kubernetes cluster right now, I'm gonna bet you good money that there's gonna be a very good business case in 5 years to get people off this then legacy tech debt platform. So how do we get there, and what exactly do we get from this approach? I'm gonna show you with a very simple web application, but this talk is not specific to web in any meaningful way, but it is just the simplest thing to talk about, and it's a nice building block by itself. And while I'm talking meta, there's as usual going to be a page with all the links and all the concepts, which you can read up if you're interested to learn more about what I'm talking here. Especially because I might have to speak a little bit faster due to the little tech problems. But now, let's behold our application, which we're going to make web scale today. So this is a very exciting pyramid view. I don't know, how many of you have ever used pyramid? Okay, just as a counter test, how many of you have ever used Flask? Okay. Armin, this one goes out for you. How many of you have ever used Falcon? Okay, Falcon is pretty cool, you should try it. So, anyhow, we are gonna teach you some pyramids tonight. So, this is a view, and just as with Flask, to run this, you need to create somehow a whiskey application. And how you do that depends on your framework. In Pyramid, it looks like this, basically. You usually have some kind of function that returns it, and that return value of that function is something that gets passed into whiskey containers, so into uWhiskey, gUnicorn, whatever you're using or liking. Now, I personally like to call it app maker because it makes an app. Well, it kind of makes sense. And this initialization code is notoriously hard to test because the differences between development and production are usually on the outside, so it's very hard to simulate the differences in the environment. So your goal should be to keep this one as simple as possible and have as few branches, like if branches, between testing, production, and development. And this principle is not different or not specific to web or whiskey at all, because you always want to isolate the creation of your application. You want to isolate the part that interfaces with the outer environment. So at some point you arrive at a point where you're just passing around Python objects and calling functions with objects, and do not just grab into the environment. So this is basically where you wire up your application. So in Pyramid, it works like this. You create a configurator object, you add routes, and at the end, you call a method on it that will assemble this configuration into a whiskey application. A whiskey application, for those who have read one of those tutorials, is just a function, basically. But that's not important here. We now have a function that creates a whiskey application, and this we can now pass into a whiskey container. And it comes up, and we can curl it, and we even get access log in Apache format for free. So now that we have something to deploy, let's think about how we do it. So we could just use this and put it into, I don't know, systemd or Docker, but then your choice of whiskey container and the options would bleed into your configuration, which is not great, because once you want to change the options to your container, or once you want to swap out the container because some hot new thing came around, you will have to coordinate the changes between your code, your dependencies, and the configuration that runs it, which is not ideal. You can do it, but you have new moving parts, and this can be hard to orchestrate, especially if you have a bigger fleet of services. So this is not great, this is error prone, so what do we do instead? And I want you to zoom out and remember to stop thinking about it as a Python application. It's just an application, it is a building block. And we want to have a standardized way to start this application, no matter what's inside. It could be C++, it could be Node, it could be Python. It doesn't really matter. So what do? Well, we do what our ancestors in the 1970s did. We write a shell script. Well, maybe not your ancestors. Yeah, and this script you just check in along with your application. So this script becomes kind of the interface between the environment and your app. And when you change the dependencies or the options, you can also change it there, and the deployment is just one step, which is nice. Now, how you call this script, it's up to you. In Docker land, it's usually called docker-entry-point.sh. You may have seen that, it's the standard. But I'm just going to call it runapp.sh because it runs an app and it's short for my slides. Now, a few things to notice. This exec is very important because it makes sure that your application, that a shell script process is replaced by your application's process, because otherwise you would not receive any signals which you want. I will talk about it a little bit more. And this second thing here, straight from the 70s, means that your standard error output is redirected to your standard output stream. So that means that you have only one output stream that you have to care about. All right, so now this script is your adapter between the world outside and Python. And the world outside doesn't need to know that there's Python inside, which is nice. And this works in systemd. Did you, by the way, see Leonard Pittering, the inventor of systemd, is around? So it's kind of exciting. It works in Docker, and it's actually best practice in Docker. And it works in proc files, which you may know from Heroku, for example, or for applications called Foreman, Forgo, Honcho, which allow you to define in development your servers, and it will just spun them all up. So that's kind of useful. Now let's have a quick look what we have. We have our black box, our building block. It's very easy to run. You just run a script. It serves on localhost. These are the default values. It logs to standard out, which is great. This part we've at this point nailed, because in development, standard out is your terminal, which is what you want. You want to see what your program is telling you. In production, depending how you deploy, it can mean that systemd catches it and sends it to syslog, which means you get 40 years worth of Unix log handling experience. If you're running some fancy cluster like Kubernetes or Nomad, you get first-class support for streaming the logs over the network to your terminal to check what your app is doing. You get first-class support to stream your logs to a log aggregation system like Logstash and Kibana, or Graylog for all I care. So this is done. So please do not try to log to files unless you have a really good reason. And God forbid, do not rotate your files yourself. You're going to give yourself and your operations staff a lot of headache down the road. Now, I think it's fair to say that this application has clear interfaces, right? I mean, they are constant. This is awesome. You have one thing going in, two things going out. Nothing ever changes. Now, on the next steps, I want to make this more realistic. I want to add features to make it actually useful. But we want to stay as close as possible to this ideal. And for the first thing, we will tackle the most glaring problem, which is exposition. Exposing only on the same host on a certain port can be useful if you deploy only one app and you put an Nginx in front of it. But it can become a problem quite fast. So let's shed those shackles and let's look at configuration. And let's start with one shift in thinking. And I want you to realize that the application configuration, like your application's configuration, is fundamentally something different than a configuration of a general purpose program like Nginx or Postfix or whatever. Because those programs need to make happy everyone. Your application has only make to happy you. So instead of thinking about what could be configurable at some point and finding some weird ways to do that, you have to ask yourself, what varies? What varies between deployments? What varies between environments? And it turns out it's usually very, very little. So there are things that do not belong into your configuration files, like your routes in web development or your middleware, or even logging. Like, let's talk about logging for a moment. So usually you want to configure only two things in logging. The one is the log level. You may want to have a more verbose log in your development than you have in production. That's one thing. And the second thing is the log format. You want to have, again, two versions. You want to have something human readable, maybe even with colors in your terminal, and you want something machine readable, which can be which can be JSON, or it can be something key value based. It doesn't matter. Something that the machine will read and parse for you. So and that's all. So instead of checking in some crazy ini files that configure logging, you just have two options, and you put the two configurations into your application. And then you switch between those configurations based on the configuration from the outside. So basically something like like the log level you can pass right through, and if format equals human, then use this configuration. If format equals production, use this kind of configuration. And this you can test, right? You can unit test your configuration because it's just switching using a variable. And you do not have huge blobs of ini files in your configuration, which you cannot really test outside without copying files hands and forth. So So what do you need to make configurable? Well, exposition is one thing, which is why I started talking about it, like the address and the port of your service. You need to configure external resources like databases, the credentials for the databases, web APIs that you are using. Those kind of things is something you need to configure. So now that we've identified the few options you need to set, so how do we pass them into the application? We could, of course, use an ini file, which is very easy. It's easy to write, and Python comes with built-in support for ini files, right? But there's a few problems with ini files. So the first one is, depending on your environment, it can be hard or even impossible to inject a proper file into it. And the second problem is that some of those options you do need in your app, like the log level and the log format. And the other two options are for your whiskey container, for the unicorn. So how do you get it? How do you separate that? You could start parsing ini files in your shell script, but that's not something I would recommend. So what do we do instead? Well, let's look back again. And is there something that is simple, reliable, and portable for passing key value pairs between processes? Turns out there is. It's called environment variables. And they are not only useful for a simplistic problem, they are universally supported for a good reason. So again, systemd, first-class support. Docker, in Docker files, first-class support. And of course, every single cluster scheduler does have first-class support for environment variables. Of course, there's a bunch of tools for you when you are developing and using. So direnv will set environment variables if you enter a directory, and there's like 500 more tools that do just that, written in every single programming language on Earth, because everyone wants to have one of their own. Service discovery and key value stores like Consul or etcd have their own tools that will just map the data from the data store into environment variables. And if you want to consume variables, it's of course universally supported by every programming language. In Python, it's os.environ. If you really need or want a file, there is a very old tool called env-zapst, which is part of the getText project, which is for translating applications, and it will allow you to do simple templating using environment variables. So again, it's very commonly supported. But there's also more powerful ones like Consul template, which allows you to do like more serious templating using, unfortunately, Go templates based on Consul contents, and Vault, and confd, which is even crazier because you can pull out data out of Redis and put it into environment variables. It has very broad support. Now, let's get back to our problem. And it turns out that there were people before of us who needed to configure the host and the port of a web service. It turns out it's even so common that there is a standard. And so there are standard variables. And they are called appropriately host and port. So conventions are great. So if you remember, I talked about foreman and proc files. So if you define multiple services in such a proc file, it will enumerate the ports for you, so you don't have to do it by yourself to avoid conflicts, and it will use the port variable to set those ports. So even if you're writing your own application, using something like AIO HTTP or something, you should really use this convention too for yourself. Now, logging is easy enough. You just pull it out of the environment and you're done. However, fuzzing around with the OS.env environment is tedious, ugly, and it's like super global state because you're groping into your process space. And it wouldn't be me if I would be talking here without plugging another project of mine. So let me introduce you to environconfig. And I know there are similar projects on PyPI, but none of them does, or at least did, the same thing when I was writing this. So what it allows you to do is to declaratively define your configuration using classes, and you can even nest them. And when loading those configurations from the environment, those names get concatenated into the names, and then you can just access them as normal nested classes. The law of Demeter be damned. So it is based on attrs, which you may or may not have heard of. So there's a lot of stuff you get for free when you're using that, like validators or converters. So for example, I really like being able to convert certain values into enums, because it allows me to limit the value space of a configuration very easily, and it will just explode if it doesn't contain a valid value. Now, I like to put this kind of stuff into a file called config.py because it's a config. But this file does not actually load it because import side effects are kind of evil. So what do we do instead? We could load it in the make app functions I've showed you before, but it's also not ideal because I like to use the make app function in my tests to create fake applications for unit tests. Oh, well, for functional tests. That's not a unit test. And it would be really nasty if I had to patch the process environment in order to configure my application and testing. So what I do instead, and what's common practice, is to have another file. And with another file that does all the dirty work of interfacing with the environment. And a common way to call it is just whiskey.py. And this is how you load the configuration. You just environ.toConfig, and then you pass in the class that you have defined in your config file. And now this file becomes the ultimate interface. It has an import side effect, which again is ugly, but there's really no way to avoid that, given how Whiskey works in Python. But the nice thing is that make app now only deals with a regular Python class with a well-known structure, and it's not some dictionaries or something like that. And you do have full control over app instantiation, so that makes it very easy to create fake or test Whiskey applications. Which means that on the outside, you have the literally lowest common denominator of key value pairs of environments. And on the inside, you have validated, structured data, which is easy to work with. And this is, again, not specific to web or Whiskey. You always want to keep the validation and transformation of data at the edges so that your application can rely on the data you're putting in. So this could be just as well as CLI entry point if you're writing tools. Now you may have noticed that now I'm putting the Whiskey application into a variable. So there's two reasons to that. First of all, not all Whiskey containers do support the way we use it with GUnicorn, where you call a function. They require you to pass a variable. And secondly, now we need to pass an argument into our make app, so it doesn't work like that anymore. So I'm calling it application because it's another convention which allows you with most Whiskey containers to just pass the module name and you're done. So our run script got even simpler. We just pass the module name and it works. Now, with all this talk about environment variables, there's one thing I left conspicuously out. And that is that time has shown again and again that certain things just do not belong into environment variables. Because some things you want to just whisper gently into the ear of your application and not make it global to our entire process tree. Actually, yeah, because your sub-processes also inherit this kind of stuff. There are a lot of ways environment variables can leak. They leaked before. They leaked for very big companies, for very smart people. And it doesn't even have to be your fault, but it still may happen to you because you just used some module from PyPI, and for some reason it just dumps the environment into the shell, or into, even worse, into a page, the web page. So I'm going to be very clear here. Do not ever put sensitive data into environment variables. And I really think that the 12-factor app manifesto has this one wrong, and I hope they will fix it one day. And this is not like my personal opinion. This is quite widely accepted. That they got this one wrong. And one of the reasons why they may have not fixed it is that Heroku doesn't have a great story around secrets management. So there's some hope that they maybe figure it out eventually. But now, things get a bit hairy because the solutions, especially the best solutions, are platform specific. And each platform has their best solution for secrets management. And just giving you a rough overview about secrets management is a talk by itself. And fortunately for you, this talk does exist. It's been done by my friend Noah Kantrowitz in 2016, and he gave it at multiple Python conferences. And there you will see that this is not a simple topic. So for completeness, we personally, since we run everything on Metal anyway, we use HashiCorp Vault, which is an open source project from Hashi. And you can use it anywhere. So this is like the only solution that is not platform specific, and it works quite nice. It's vendor independent. So one more detail, since we run Nomad, which is also from Hashi, so they work quite nice together, and we use built-in templating, which allows me to put secrets into a file, into a special file system, and read it from there, which is not perfect because files can also leak, but they're much less likely to leak than environment variables. So I think this is a decent trade-off. Well, but the safest way is sadly platform dependent. And you always have to go this way if you need dynamic secrets. So for example, if you are doing frequent secret changes and things like that. And so what do we do in programming when we need to abstract away a platform-specific detail? Well, we write a facade. We just wrap whatever we are using into something more universal. So this is how it could look for Vault. This is how the Vault client works. And we just wrap it. And now we have an own interface. It's called the get database URL. And this is the interface we are going to rely on. And in your application, you're not going to care about whether this secret is loaded on instantiation or whether it's loaded whenever you call on it. That's a problem of the people maintaining the secrets backends. In your application, you just say get db URL, and you've got your URL. And if your backend, your secrets backend changes, you just re-implement it, but just keep the same interface. And your app does not have to be changed at all. So this is kind of nice. And of course, for tests, it's very easy to fake out. You just return static strings, and you are done. There's one thing I'd like to point out. I really like to encode secrets in URLs, as I've already mentioned. And a lot of libraries have first-class support for that. For example, Redis, SQL Alchemy, and there's also an extension for Django that will allow you to do that. And the reason is similar to what I've talked before. Because if you put the secrets and, let's say, the host name of the database in two different places, whenever you want to change them, you have to coordinate. And once you have to coordinate two changes, eventually you will screw it up. That's just the law, Murphy's law. So I like to keep them all together, and that way I can change everything at once, and it cannot happen that I have a mismatch between a host name and the credentials. There's a lot of libraries to create and to parse URLs. I like a Russian one actually, YARL, which is used by AIO HTTP, but pick whatever you like most. All right, we still do have a nice building block. It's still very easy to run. We inject the information that we want using environment variables, and we inject only these things that vary over environments and over deployments. Secrets, they are not as elegant, but with some effort it becomes good enough. We expose using our configuration, and we log according to our configuration. So far, so good. Ah, sorry. But a keen listener might have noticed that there's one problem with this. You cannot reload your configuration, right? You cannot just change the environment variables of a running process. Well, you probably can, but it's, let's say, not best practice. So I would like to reframe this problem as something that's actually positive, because it forces you to think differently about this whole topic. Especially, it forces you to think about zero downtime deployments, because that's your solution. If something changes, you just redeploy your application. And the sooner you do that, the bigger the payout, because the easier your deployments are from day one, and especially the easier it is to implement before your application becomes more complex. So thanks to our building block, though, it's really, really easy to achieve that too. So instead of having one application, one instance of the application on the same host, you just put two of them. They can still be on the same host. They just listen on different port numbers. And then you put a load balancer in front of them. It could be Nginx, it could be HA proxy, it doesn't matter. And now your application will never have to listen on a privileged port, which is also a whole lot of problems you don't have to deal with. And your only application's duty to deal with this changed configuration, this change in architecture, is to figure out client information from the load balancer. And for that, in HTTP, we do have standardized headers, like X forwarded for or forwarded. And if you're writing a network application, there's the proxy protocol. Now, if you want to deploy a new version of your application, you do a so-called rolling update, which means that you tell your load balancer to ignore one of your instances. And now you can do whatever you want, because nobody's going to be affected by the changes you do to the one instance. As long as your app goes down cleanly, and there's nothing you have to worry about now. At this point, I want to do a little detour, because one problem I saw a lot with Python applications is that they listen for the wrong signals. And you have to make sure that you listen for sigterm, which is the standard signal used by all process managers. This is the standard one. What many Python applications just listen for is the keyboard interrupt exception, aka Control-C, which works really nice in your terminal. But then you have some weird behavior when you put it into production. And the problem is that your process manager sends your application sigterm, your application ignores it. The process manager, depending on how it's implemented, waits for some timeout, and then it just kills it with sigkill, which your application cannot do anything about it, which means you have very slow It takes a lot of time to quit your application, and you don't have any benefit from it, because your application doesn't know that someone is waiting for it to quit. So make sure that you listen to it however you have to do that. The situation improved a little bit in the past year, but it was very common to just wrap your applications in try except keyboard interrupt and call it a day, which can give you a lot of headaches once you have to deal with something like Docker or Kubernetes. Now, once your application is down, you can do whatever you want. You can deploy your new code, you can change your configuration, you can test locally, you have all the time in the world. And once your app is ready again, you just put it back into rotation. It's easy like what? And the nice thing is also that you leave the reloading of your configuration and the changes in the routes to your load balancer. And this is also a much more complicated problem than it sounds in the first, when you first hear it. So it's really nice to be rid of this problem specifically. So again, another problem that someone else has to solve. So Now, another upside is, of course, that if a deployment doesn't go quite as planned, which I heard happens occasionally, what do you do now? What do you do now? Well, you do nothing. That's the nice thing. You do nothing because nobody knows that your server is on fire. So as long as you don't sweat too much, your coworkers will not know. So instead, you just breathe, you do not add it back to your load balancer, and you take your sweet time to investigate what went wrong. You can do an easy rollback. So even if you deploy using git pull on your production service like an animal, you still benefit from this approach. Okay? So no matter whether you have a sophisticated cluster scheduler or an intern with an SSH client, nobody will know. It will just work fine for you, and you have less headaches. So there's one topic that always pops up when I talk about this, and it's schema migrations. Yeah. So the answer is very, very simple. If you really need to be able to have deployments with schema migrations and zero downtime, you have to put in the work to make your application to work with both versions of the schema, and that's the answer. There is no better answer. So either you just eat up a downtime, or you have to put in the work to make your app work with both schemas. There's no shortcut. All right. So there's one thing I hand-waved over a little bit, and that's when I said that it's added back to load balancing when it's ready. But how does the load balancer know that your application is ready? And for that, to know, we need to add another interface. And what we need here is introspection from the outside into your application. And this is a very, very powerful concept. And the nice thing is that it's a powerful concept with a very simple solution, and it is that you offer a web endpoint that allows you to reach into your application. And again, it doesn't matter what kind of application it is. For web applications, it's obvious that you just have an extra host or an extra route. But even if you're writing something completely different, as long as it's long running, you can expose a web endpoint, and you don't even need an additional dependency because the Python standard library comes with http.server out of the box. I'm sorry. So what your load balancer needs is to know about the readiness of your application. So what is readiness? Readiness means that your application is ready to serve, so that it's ready to be added back to your load balancer. And for that, you will expose an endpoint that checks all the resources that your application needs to do its job. And depending on the result of these checks, it returns a 200, everything's fine, or 500, I'm on fire, please ignore me. And unfortunately, there is still no clear standard on how to call or structure these endpoints. You may have heard of Health Zido from Google, which there are multiple legends about where the Z is coming from. My personal favorite one is that it's Google Great Security by Obscurity, but it's probably just some clash avoidance. But still, they were used to expose their health endpoints on the public internet, which is kind of funny in hindsight. So Mozilla has something called Dockerflow, which is like a whole concept and like a process on how they work with introspection, and they use dunders, so it's very Pythonic in a way. And finally, one common approach is to just literally take ready or readiness, and that you use this namespace with a dash in it. And I'm personally a real fan of the dash namespace because it clearly separates your introspection endpoints from the rest, and it's super easy to block in your edge load balancer. So this is HA proxy. It's one rule, one line, and you're done. Nobody will ever get on your introspection stuff. There is one downside of readiness, though, and it's that it's quite expensive because you have to ping your database, even if it's just a select one. And so I do not like to do it too often, and sometimes you also do not. Sometimes it's just enough to know whether your application is healthy. Just the application, not what it uses, the application. Is it alive? Is it healthy? And that's where we start talking about liveness. And liveness is very cheap. Liveness just means that your app still reacts to requests. And this should be relevant to your process managers and to your cluster managers. Because if your app starts failing, it means that it's in a deadlock and it needs to be restarted. It cannot help itself. If the startup fails, it never reaches the liveness, it means that the deployment went wrong and that you need to roll back your deployment. Now, again, there are multiple common names. There's -healthy, which I personally find very unfortunate because it's as close to health-z as it possibly can be. Then there's liveness, and Mozilla likes to use LB heartbeat. So what's interesting here is that Mozilla apparently uses this kind of uses liveness for the load balancers and not readiness. And I'm on the same side, to be honest, because first of all I like the cheapness of it, that you do not strain your other systems with it. And most of my resources, like my database pools, they are lazy. So they connect on when they are required. So once my dash is ready to serve, it's fine. And I can serve better errors anyway than the load balancer when there's no backends or something. So this is something taken straight from production. This is all it takes. You just return plain text, you put no permissions into it, and you're done. So once you add this to your routes, you're ready for load balancing. And again, my pool is, when this starts to serve, my pool is already initialized, and I can deal with the errors better than anyone else. I also do have one of those traditional expensive endpoints, but I personally use it for monitoring. So once the apps start reporting problems with databases, I know what's going on. So this is a trade-off, of course. You have to pick for yourself. One of the reasons I go for the cheap one too is because, as I've said before, I use Nomad and Consul, and they only have one type of service check. So Kubernetes, for example, does have both types. You can make them check for both liveness and readiness. I do not have this option, so I kind of have to choose one over the other, and I chose the cheap one. So yeah, sorry, this is all it takes to be ready for load balancing. Now, of course, there's no reason to stop here, because now you have an interface into your application. So what else is possible? So Mozilla has a standard of getting the version of their application. It is running right there. If you like pool-based metrics like I do, Prometheus, you can put them there too. And something like logging. Maybe sometimes you just want to set the log level right now because your app is misbehaving. But if you redeploy it with a new log level, the misbehavement can go away. So it's nice to be just able to just send a post against an endpoint and set the logging to debug or something like that. So all it is to say that you basically use it for everything that you might have used Unix signals before. All right. So now that we have taught our application to talk to a load balancer, we gain an incredible amount of freedom, because now we can scale up and scale down as we need. It's just like magic. And of course you can take this even further, because the load balancer doesn't care where those applications are running. So how about we just distribute them over servers? No problem. You use an internal network, you can now use the same IP all the time, everything works the same. But now you run into a different problem. When those apps run on different servers, they obviously have different file systems. So you could start doing some magic with NFS, or God forbid Samba, with some kind of locking. I'm going to say that it's not advisable if you like your sleep. So instead, again, we have to rethink the problem. We have to embrace it. So in this case, it means the file system is lava now. One of the classic file systems that people encounter, we've already solved. We log to standard out, and the environment just handles whatever you throw at it. It can write it to a disk or not, or it may send it to a different host. It's not your problem, it's someone else's problem. Another classic example is state, like user sessions. You need to be able to access those user sessions on every single host, because you don't want to have your users to be logged in on only one of the backends. That would be kind of crummy user experience. So basically, once you have some data that you need to access on all hosts, or it needs to be permanent, you need to put it into an external service. And that means no files for you, nor SQLite for you. It means that you have to learn to love external storages. For example, Postgres, which is basically great for everything, and very few people outgrow its scalability. Then there's things like Redis and Memcache, which are great for caching and for session management. Consul and etcd, they are good for key value storing in real time, and they are great for service discovery. So this is where your data goes once you are not allowed to use your file system anymore. Now, when you look at this once more, there's another problem. And the problem is that managing this many hosts or servers or containers or whatever is a pain. For simple setups, you can still get away with something like shell scripts or Ansible or something like that, but it still can get complicated very fast. So let's get some help. So I think that I'm pretty much on record at this very conference that I think that Docker by itself is kind of meh. I still don't think that Docker is very exciting by itself, although it is at least stable now. I had no outage caused by Docker in months, so that's good. But it's not very exciting by itself, but it caused an industry packaging standard which abstracts even more of the application away. And more importantly, it created an ecosystem around itself, and that's the exciting part. Because with that, we got cluster managers. And cluster managers are the actual game changer. Docker is just an implementation detail. And once you have one of those running, so it's Kubernetes, Mesos, DCOS, and Nomad, once you have one of them running, you can say, this is my container, these are my hosts, running on one of them, and I don't care how the app gets there, which is very freeing. And your applications become even more ephemeral. And now you have to deal with things like very short lifetimes, because your app might be shuffled around. It might, nodes may be going up and down because you're scaling up and down, or your nodes may be rebalancing themselves so that just an application gets moved to a different node. So this is another reason that you cannot rely on the file system. It can get stale very fast. And this also means that your application is ready for a multi-data center cluster without knowing about it, because all it knows is how to start and communicate readiness, how to serve and communicate health, and how to stop reliably. That's all it has to know. So we got to web scale by doing less, which is nice. And at this point, I could start talking about things like service discovery, meshes, like Linkerd, Envoy, Istio, all the hot stuff right now, but they don't fundamentally change anything about your application. You just have to abstract away the communication between your services. So that's another talk right there. So instead, let's just have a final look at our application. So it is still a black box. We don't know what's inside. It's easy to start using a shell script. It's completely self-sufficient. You pass your parameters in as environment variables. You have a clean shutdown with standard signals. It magically retrieves its secrets. So security is always a trade-off between convenience and security. So this unicorn up there is just plainly your decision and how much money you're willing to invest, how much time you're willing to invest, and how you're how much time you have for this problem. So it keeps your data in external resources so it doesn't get lost. You expose your service according to your configuration. you expose your state at a standardized web point, and your logs still go to standard out. That part never changed. So that can be picked up by the environment, or it goes straight to a terminal. And for all of this, your app hasn't changed at all. It's still the same app as before, and only the things around of it changed. And you gave up responsibilities, which is kind of nice. So one final thing, let's squirm a little bit and think about what we just said. So we want to have an app as a black box with clear interfaces that enable loose coupling with other components, with other web services, with load balancers, and stuff like that. We do separate I/O from logic. We log to standard out. We push configuration from the outside and transform into classes as soon as possible. So you only so you have pure data as soon as possible and do not pull it out from the outside. And finally, you isolate your process as well as you can. Your global state is handled in one spot, so you can oversee it easily. So this is all best practices from software engineering. Particularly, it reminds me of the hexagonal architecture by Alistair Cockburn. So I guess the lessons that I'm trying to get through here is that your applications boundary is just another boundary in your overall software architecture. And your application is, or it could be, part of something much bigger. But also, as with all software architectures, what I've shown you here is an ideal that you may not be able to follow, because not every app fits the constraints that we build up. I have plenty of regular apps too, and someone has to write to disk eventually if you don't want to lose your data. So, and some of the things I said today contradicts my talk from last year, which I couldn't present here because I was traveling, where I said that you need to have as few external dependencies as possible because each of them is a liability because it can go down. And both things are true. Both are solutions to different problems. And your task as a software engineer is to choose between them and make an informed decision and make the right trade-offs. So what I'm saying here is to come to all of my talks and make informed decisions. So one more thing, then I'm done. Don't we all crave realistic examples? But companies tend to not expose how exactly they're deploying their applications. They use buzzwords like continuous deployment, chat ops, and whatnot. But in the end, it's usually just some shell script that has been written in 2002 by some intern who cannot be tracked down anymore. Nobody knows what the script is doing, so nobody's ever gonna touch it again. Yeah, you're laughing. You know it's true. So fortunately, we do have a great open source example of a modern Python application that runs at scale. And I love coming back to it, look at it, and to learn from it. And it's, of course, PyPI, the new PyPI that has been deployed this year. It serves over 6 billion of requests per month, which are about like 1.5 petabytes of data. That's numbers from March or something. It's probably like twice as much by now. It does so really fast. And yeah, I've spoiled that over. It does so really fast, so it's a really great thing to learn from. Yeah, so that's all I have for you today. Please check out my talk page. The QR code will get you there too. Follow me on Twitter. I'm sorry I talked so long. It's not my fault. My notebook just didn't play along. Have an excellent PiterPy. It's always great to come back. Thank you very much.
Thank you.